Hi, this is the chapter 12. We already discussed in class, which is the sound wave. You know that everywhere, if you go outside, you can hear the sound. I'm speaking here, you can hear the sound. As we discussed in class, you know that if there is no any medium, there will be no any sound. That means to travel the sound, we always need some medium. That may be gas, liquid, or solid. Okay, therefore, in these chapters, mainly you will discuss about characteristic of sounds, what the intensity of the sound level is. You know that, I'm speaking now. I have my intensity, some specific value. If you hear the sound of mosquito, you'll hear one sound, one level of sound, a thunderstorm, or different ways of sounds you can hear with the different intensity. Um, you will also see different videos I have posted here. I showed you in classroom as well. What is the function? How does that work? Human ear. And also what are the sources of sounds? You go everywhere for the musical night, okay? You will hear the guitar, different flute, or different sounds here. Okay, water sound. If you go to the ocean, you will hear the wave, sound wave. The sound of water wave. It means like a different sounds for different characteristic of sound you can hear. A noise. If I sing a very nice music, nice song, then you like that. If I could not sing the nice song, that means you'll think like, oh, that's a noise, not the harmonic sound. Okay. There is another Doppler's effect, as we discussed in class, very important. Shock waves and applications in these chapters are very important for these sections. I strongly recommend you to go through this YouTube link I have brought for you. In the first link, you can see human ear and the interaction with the sound wave. How does that work? And similarly, what are the different sound levels we are facing in the everyday life? You can hear some harmonic sound, which is very noise sound, which is very dangerous sound that can pain your ear. You can go through this website, YouTube link. And Doppler's effect is, as we did one demonstration in classroom, that by closing your eyes, you can easily figure out if the person coming towards you, if the sound coming towards you, or sound going away from you. You will also know about that. General concept of waves, wavelength, frequency, different pattern of the wave you can see through this web video link. And ultrasound, how does that work? It shows clearly in this YouTube link. Therefore, I strongly recommend you go through all this YouTube link and get idea. And in this class, mainly I want to talk about the mathematical sections here. The main mathematical problem is from the physics 1. We know that always if the speed is uniform, there is no acceleration in particular directions. If the speed is the same or velocity is the same in a particular direction, then the formula is simply d equals to v times t. V is the velocity and time, because there is no acceleration, because the velocity is uniform. Everybody knows that if the velocity is uniform, there is no acceleration. For example, very simple formula. This is from the textbook of problem 1. A hiker determines the length of a lake by listening for the echo of her shout reflected by a cliff at the far end of the lake. She hears the echo 2.5 seconds after the shouting. Estimate the length of the lake. It is very important. You know that if you are here at this point, you have this mountain. This is all the lake here. Then what happens? The sound goes and reflects back from this mountain. And this says that the question says, if this guy hears, a hiker hears the sound after 2.5 seconds, that means the sound has to travel up to here and then come back here. Since the sound travels with the same speed in the same temperature, and therefore total time is 2.5 seconds. 5 seconds means one way time is just half of that, that is 1.25 second. Okay, therefore, therefore, you know that, in this situation, just very simple formula, distance equal to velocity into time, at the room temperature, simply we can take 343 meter per second because it has been given here. If not, usually you can choose 340 meter per second, the same thing, but the velocity is given in these questions. Therefore, just use 343 meter per second into time. As I told you that one way is 1.25 seconds, and therefore total is 430 meters. Now, next one is intensity level. This is a decibel. I told you, I discussed this problem in classroom as well. Beta, which is represented by decibel, is equal to 10 logarithmic I over I0, where beta is the sound intensity level in the unit of decibel, is intensity in watt per meter square. I0 is the threshold intensity of for hearing. You can get one problem. For example, if you have suppose pain level of 120 decibel, and whisper is you have your pain level, intensity of a sound at the pain level of 120 decibel, and it is compared to the 20 decibel. Use this formula here. The decibel is intensity level is 120 decibel is equal to 10 logarithmic I 120 by I0. I0 is the threshold of hearing. Then I 120 will be equals to divide by 10 gives you 12. Then logarithmic always goes to the 10 to the power 12 I0, and I0 is the threshold of hearing, which is equal to 1 times 10 to the minus 12, which is the intensity level of this. Intensity of this intensity level is 1 watt per meter square. And similarly, what about 20? Do the same thing, same formula, and intensity of the 20 is at 20 decibel is 1 times 10 to the negative 10 watt per meter square. Then if you take the ratio of this, then you can find out 120 decibel is in intensity, sense of intensity, it is 10 to the power 10 times more intense. You can imagine that how intense of sound it is in comparison if you have a 2 decibel comparison. Similarly, next point is Doppler's effect. It is very important for the light, study of light as well. And you know that Doppler's effect is simply, it tells about the frequency, change in frequency. You know that when you close your eyes, then if sound is coming towards you, then the intensity is intense, more intense. And if you go away from you, and then you know what happens, the intensity is decreasing, and therefore f prime is equal to f over 1 minus v source over v sound. This is the mathematical formula. We have derived this in classroom. I just want to bring up here the mathematical formula. Just focus on this formula and apply how to use it. And therefore, when source is moving towards you, for example, if you are standing at a point and a bus is coming towards you with a siren sound, or sound, that then it is the source moving towards stationary observer. The case is this. Similarly, if you are standing at a point and the bus is moving away from you, the mathematical formula is the new frequency you hear is just minus to plus here. Similarly, observer is moving towards stationary source. You know what happens, rather than, a bus is standing at a point just producing the sound, you are moving towards the bus, and then you will get this formula here. This is technically the similar formula. If you divide by this, then 1 plus v sound over v, if you divide this, then you will get the formula here. Similarly, if observer is moving towards the stationary source, you will get the same thing here. Either way you can write it. And now you can get the problem here. If you read the problem, the question is, for example, this is from the textbook, the predominant frequency of a certain fire truck siren is 1650 hertz when at rest. What frequency do you detect if you move with the speed of this toward the fire truck? If you move toward the fire truck, that means observer is moving towards stationary. Then use this formula, okay? use this formula, which is this value. Similarly, if observer is moving from away from a stationary source, choose this formula here. Okay, you are choosing another formula here, this formula. Okay, source is moving toward the stationary observer. The idea is, either way you can find out. Mainly point is you need to find out what the problem tells about. Either the source is moving stationary object, or object is moving towards the stationary source. You need to figure out and choose the mathematical formula. And finally, this is all the things I showed you here. If source moving towards observer and observer is also moving towards source, means they are coming towards each other. What happens here? This is the mathematical formula. If they are moving here away from that, then this is the mathematical formula. You need to figure out what the situation is, choose the mathematical formula and apply. Okay. Similarly, all the conditions, all the mathematical formulas are given here. Now, next problem is here from the textbook, problem 63 of chapter 12. If you think about it, a police car standing a siren with a frequency of 1580 hertz is traveling at this much 120 kilometers per hour. What frequencies does an observer standing next to the road hear as the car approaches and as it recedes? That means what happens if car coming towards you and then leave you, or it moves away? There are two conditions you need to figure out here. Observer is stationary and the source is moving. First the source is approaching and then the source is receding. You need to use this formula here. There are two different formulas here. Source moving towards, use this formula. Source moving away from this, use this formula. Okay, two different formulas. When that is coming towards you, this much value you hear, more frequency you are listening. And when source moving away from you, you are listening this frequency, and just calculate that. Both the observer and the source are moving, just use this mathematical formula. And approaching, I told you that just use the formula and find out what situation it is. And then both observer and source are moving. Again, use this equation as I given you before. The idea is you have all these mathematical formula and then choose based on the questions, what the question tells about, what the question is telling you, what the situation is, then figure out easily, and then you can work on it. Okay, therefore Doppler's effect, one of the very important topics here. And then next one is very simple formula, velocity equals to distance into times. And another very interesting formula is intensity level. Always we measure in the decibel, and its formula is this. Watch this all YouTube video, then you will be master in chapter 12. Okay, this is all for the chapter 12. Thank you.